Hello, and welcome back to another Hello Neighbor Unreal Engine tutorial. And today, after 10 months, we're finally going to be covering idle tasks for the Neighbor AI. Before we go, I would just like to mention that pretty much half of you watching are not subscribed. You know what this means. Do it. Alrighty, if it could unfreeze Unreal Engine, can you please not freeze? Okay, after that little setback, let's get started. Alright, so first we need to create a couple variables. So the first thing that we're going to want to do is make an integer variable called idle task. Set that as an integer, and the reason for this is because we're basically going to randomize this integer from 0 to however many idle tasks you are going to have. And by the way, this does not mean 1, 2, 3, 4, 5, 6, 7, 8. No, it starts from 0. So instead of 1, 2, 3, 4, 5, 6, 7, it'd go 0, 1, 2, 3, 4, 5, 6. If that makes any sense. So yeah, we'll basically be using this to randomize the idle task, but we're just gonna do one idle task just so you can understand how the whole process works. So once we've created that, we're also going to want to go into the setState function, right click on this, and do promote to variable. And call this current state. The reason for this being is so we can actually check the current state in wherever we'd want the wherever we want, basically. Like wherever we'd want to check what state the neighbor is in, we just use this variable. I have no idea why I didn't do this in the first tutorial, but well, we have it now. Alright, so once we got that done, we're going to want to go into the behavior folder and click on the neighbor tree, and this is where all the magic happens. So you remember how in the setState function you have the set value as enum in the get blackboard? Well, this is what I mean by that. The blackboard has this variable called state. And since this variable is getting set in here, it is getting the blackboard of the controller of the AI, which is neighborCont right here. And since it's running the behavior tree, and since the blackboard is associated with this behavior tree, it's going to be using this blackboard. And so basically they're all connected together, and that's why you can use this variable in here. And so off of here, we're going to click new task, and this is by default going to be named BT task blah, blah, blah. So we're just want to go into the behavior folder and rename this to BEH or B or whatever you want to pronounce it. Watch TV. Alright, cool. Alright, so now that we have this task, what do we do with it? Well, before we do anything with it, we're going to need to create a couple actors. So now we're going to create a new actor class called BP Sofa. And in here, we'll create a new static mesh component and make it the sofa mesh. And now comes the very, very important part of making the actors. You need to have an arrow component. This will determine the location that the neighbor moves to and which way to be facing. So obviously we'd want him to rotate this way, because he's facing this way and sitting down. And to check the exact positioning of it, you can add a new skeletal mesh component and set this to the neighbor low poly mesh. Turn it facing so it matches the rotation of the component, and change the animation mode to use animation asset. And we'll use neighbor low poly sit. Oh. Well, that is not the direction I thought it was going to be. So just turn it around that way, and it looks to be pretty good. I'm actually surprised that I actually got it on the first try. Alright, so now you can delete the component, this skeletal mesh component, because we don't need it anymore. And so now that we have this, we have to go into the BP neighbor, create a new variable, and call it sofa. And make it public so you can change it in the level editor, and make it a BP sofa object reference. This is so we can use it in the behavior watch TV task. And so now that we have that done, we can create another actor. Actually, this has to be off of BP Interactable, and call it BP TV. Alrighty, so now that we have that, just create the arrow, skeletal mesh, neighbor low poly, rotate it, and now we can rotate it 90 degrees and set the do what we did before, set the animation mode to use animation asset, and search for TV start. There it is. And we'll basically just move him down until we get to like a good... Now that we have that done, we can delete the skeletal mesh. And actually, since he's going to be moving towards the arrow, he's just going to move to at least the location that's close enough to the arrow. So he'll move to here and play the animation just as we need it. So we don't need it to be like on the ground or whatever, because he'll still be able to reach it. It just needs to be in a place where the AI can actually, like, you know, overlap to and stuff, you know? Alright, so now that we got the BPTV done, we'll go over the TV functionality in a later tutorial. But anyways, we'll name this create a new variable, TV, make it public, and make it a BPTV object reference. There we go. And now that we have those two blueprints done, we can finally get to the task. So first things first, every single task that you make for an AI has to start with event receive execute AI. Event receive execute will not work. It needs to be event receive execute AI. And so now, off of this, the controlled pawn would be cast to BP neighbor. So now that we have that, we can drag over here and do AI move to, and the pawn being BP neighbor, and now do get TV This will be exactly the same for the sofa as well. You'll just be having him move to the arrow. So do get arrow, get world location, and put that in there. So now this is what this is doing is it's getting the TV reference, which you would set by having him in there, as well as the TV and sofa in there. Let's add it. Let's add a stand. All right. So you would have both actors in the exact same level, and you would go down to scroll down to default in the details tab for the neighbor, and you'll find that sofa and TV are able to be set. So obviously, sofa, you would select BP sofa, and for TV, you would select BP TV. Now that you know how to do that, this will he will now move to the location of the arrow E every time that this task is executed. So now that that is done, we can now go to the randomization for the idle task. Now I'm pausing this off on here because one, this is a very short section of the tutorial, and this is very important. So now we'll have to create another function for randomizing the idle task. You name this function Randomize Idle. And now off of here, select idle task, do set idle task, and off of here do random integer in range. This will be so that you can set the minimum integer it can be set to and the maximum integer it can be set to. But for now, we'll just keep it at 0 since we'll only have one idle task. So now do get blackboard, the target being self, and off of here do set value as int. Actually, I don't think we even need this idle task variable. I don't think we even need it. Nah, we don't need it. You can delete it. I always realize these things like too late. Like way into the tutorial. Alright, so anyways, off the key name, do make literal name. And name it idle task. Now you may be thinking, Owen, we haven't created a blackboard key for the idle task. And you are exactly right. So make a new integer in the blackboard and copy and paste the name that you put in the randomized idle thing. And now that we have that, it is now going to randomize this integer. So now, off of the blackboard base condition for actually we should rename this to idle mode, just to make it easier to know what mode this is, you know? Alright, so now do a selector, add another blackboard decorator, and do idle, and name it idle selection. Put a space here. Idle selection, and the key value in the blackboard key would be the idle task, and this will be checking if the idle task variable in the blackboard is equal to 0. So if it is, do behavior watch TV. Alright, so now this will basically be checking if the state is equal to item mode. And if it is, check if it is equal to 0. And if it isn't, it'll say, and if you have other idle tasks, it'll check for the other ones, and if the task selection is equal to the idle task randomization. There it is. My brain shut off for a moment. So anyways, now that we have that done, we will now test it. And as you can see, he moves into the arrow for the wait, why is he running? Why is he running? Did I? Oh! Wait, what the? Is there a thing that... I see. It's not being set. Event begin, play, set, state, idle. There we go. Now he will be walking. There we go. So, with that done, we can continue on with the task. So now, every single time on fail, you have to do finish, execute, and check success. This is to prevent him just standing there if he like runs into something. Oh wait, I just remembered. AI move to is not the best thing to use. Instead, you'd use move to location or actor. This is basically an AI move to, except better, you know. And you connect the controller to the owner controller. And the reason for this is because there are a lot more options here. And so, for instance, accept partial path. This means that if the direct path to the goal doesn't exist, for instance, if a chair is blocking it or whatever, he'll accept a partial path, meaning he'll walk to the next best location that he can move to, which we do not want that, so no. Use pathfinding, yes. Lock AI logic, we're going to need to uncheck that as well. And so, yeah, that's basically it. So now, we'll have to do on request failed, we'll do finish, execute. And not only this, we will have to drag off of as PP neighbor and do randomize idle. This is to prevent him from, is to make it so that if there isn't a path to the corresponding object for the task, then he'll do something else. So with that done, we can now make another function. Haha, yay! Now you may be thinking, why on earth would we want to make another function? Well, it's so that we can make basically a simpler play animation function. So we'll just call this play anim neighbor. So now connect that to here and connect that to here. Now, you may see this as, now this is the absolute wrong type of key that we want to use. Instead, search for anim sequence. That's the one. As you can see, it's compatible to it. But the reason why we didn't want that is because off of here, we can do get play length. And the reason we want that is so we can use a delay node. But we can't use a delay node in the function, so we're going to have to do a return and put that on there. And set this to anim length. Alright, now that we got that function, we can call that in the behavior tree, or in the task. So now, we can double click on here to make a reroute node, that way we can stay more organized, and do play anim neighbor. And connect that to onMove finished. And now you can search for TV start. There we go. And off of anim length, do a delay. And then drag off of here and do set animation mode. That way he'll be able to use his blend space animations, and he won't just stay in the last frame of the TV start animation and just slide across the ground. So now off of that, we can copy and paste this move to location or actor thing. And again, make a reroute node on here so we can stay organized. Connect that to the controller. And this time, the goal location will be the sofa arrow location. So get sofa, get arrow, and over here, get world location, and then connect that to here. And now that we have that, make another reroute node, a couple actually. Off of here, do play in neighbor. And connect that to move finished. And of course, we'll want to connect the unrequest failed back over here. Remember, you have to connect that to here for every single one of the move to location or actor nodes that you ever make in a task. So now we set the animation in the play in a neighbor node to sit. Then add a delay node. And since this is now the state where he is in the state where he's watching the TV, we can just drag over here and do another play in neighbor. And do watch TV watch main. Do another delay node. Now for here, we don't want the animation to play once and then he'll get up and turn off the TV and whatever. Instead, we'll want to do a multiply node, int by float, connect it to there, and for the integer, we can do a random integer in range. And you can really set this to whatever you want. Personally, I do the minimum of 4 and the maximum being 8. So that way he can either watch TV for just a little bit or a long while. So after that, we can do another play and a neighbor. And do stand up, delay, copy and paste move to location or actor, controller, just add a bunch of reroute nodes once more, and do get TV, get arrow, get world location, and connect that to the field. I know this looks awful, but actually, yeah, this looks awful. Let's just change that around. Add some reroute nodes, yada, yada, yada. There we go, that looks much nicer. Alrighty. Now on move finished. New reroute node. Play anim neighbor. TV start. Delay. And then set animation mode. And then we can connect that to the Randomize Idle and finish execute. And yeah, that's the entire thing. So now, let's test it. Walks over there. Oh, silly me. I forgot about one thing. We have to set the rotation for the neighbor every time we do the move to. So, yeah, now we can do get world rotation. We'll have to split this. Set actor rotation. And split that as well, because we only want to change his Z rotation or his yaw rotation. And so, once we have that, he'll actually, and basically just do this for all of the arrows and move to location or actors, so that when he actually moves to the arrow, his rotation actually gets set, so it actually looks, you know, proper. So just do set actor rotation. Split. Get world rotation. Split. And then one last thing. Set actor rotation. Get world rotation. So now, after compiling that, he'll actually turn to face the, you know, things. See? There it is. And there you go. He is currently watching TV. But, I forgot to add another... What do you know? I forgot to add another thing. Forgot to have this... Add this little looping boolean into the playAnimNeighbor function. So now we can go back into here, and for the watch main, turn looping on for that. So now he'll walk over there, turn that on, and then the animation will actually loop. Oh, what the? Uh-oh. Uh-oh. Stand. Not sand, stand. There we go. Open that up. We'll have to, go into the import settings. Not import settings. And go import rotation and set that to 0. And then re-import that. Yay! Now he'll stand up normally. Oh, and I also noticed that I forgot to add a set movement mode node right at the end here. So set animation mode. Set animation mode. And now, with those changes made, goes over, turn on the TV. And after a little bit, he'll stand up, walk over there, turn it off. And he's repeating it because the idle task is still being set to 0. So yeah, that's basically how you make idle tasks. Now you may ask, how do I make out other tasks? Well, it's literally the exact same thing as we did here. Make him move to an arrow, make him move to a location, make him play an set his rotation, play an animation, and basically do whatever you want after all of that. So, say for him making him sleep, just make him move over to the arrow, play an animation, with it looping of course, and then after the delay, play another animation, set his animation mode, and then randomize the idle and finish the execute. So yeah, that's how you do idle tasks. Literally just make him move to a place, play some animations, and then randomize the idle and do it all over again. Comment down below what other tutorials you want me to do in the future. I know this one that took way too long to put out there. It's just generally life in general just got in the way of it. I graduated from high school this year. I turned freaking 18 this year, and so yeah, I'll try to make these tutorials more frequent in the future. But anyways, that's it for this one, and I'll see you in the next one.